About 4,600 years ago, someone stood at the top of the tallest structure on Earth and placed the final stone into a perfect razor-sharp point. We still have no definitive proof of how they got there. We have records of nearly everything else from that era. We know what the workers ate for lunch. We know who signed off on limestone deliveries. We even have a 4,500-year-old site manager's papyrus logbook, written by a supervisor named Merer, who documented his crew's daily movements, their supplies, and their chain of command in half-day increments. But the actual construction method for the structure they were all feeding, completely absent, or rather, its blueprint is absent. But from the evidence we have, it is possible to reconstruct the process, and maybe we've just been looking at it the wrong way. Common sense says it should have been built bottom up, but this was Egypt's Old Kingdom, where it was believed that life and light themselves emanated from the sun god Ra through its earthly messenger, the pharaoh. Maybe the pyramid represented in more than one way the emanation of hierarchical power of the time, and maybe the pyramid itself could have started to show its magnificent final form top-down as well. The Great Pyramid of Giza originally stood 146 meters tall, contained roughly 2.3 million stone blocks averaging over 2 tons each, and its base is nearly a perfect square, flat to within 21 millimeters across its entire footprint. It's aligned to true north with an accuracy of about 1 millimeter per meter, and that was achieved without compasses, without lasers, and without GPS. As best as we can tell, they used only the stars. There's a popular claim floating around that the pyramid's latitude, 29.9792458 degrees north, numerically matches the speed of light, 299,792,458 meters per second. That sounds staggering, and the more you look into it, the more you realize that the latitude coordinates are wrong. But they're pretty close to the speed of light if you consider their decimal notation, which would be 29.979167. Nonetheless, this is the kind of coincidence that conspiracy theorists love, precisely because our understanding of the pyramids has enough gaps to fit almost anything inside. But instead of allowing ourselves to be sidetracked by inexplicable near coincidences that would open the stargates of speculative fiction while doing little to further our understanding, we can focus on a mystery more within our grasp. How were they built? Every year, the Nile flooded its banks and converted the surrounding valley into one of the most productive agricultural systems the ancient world had ever seen, generating grain surpluses large enough to feed tens of thousands of people who were not farming during those months. That surplus gave Egypt something extraordinarily rare in the ancient world: sustained time, stable labor, and the bureaucratic machinery to run massive, multi-year engineering projects without interruption. And those workers were absolutely not slaves. In fact, archaeologists excavated entire workers' villages at Giza, complete with bakeries, breweries, hospitals, copper workshops, and the tombs of the craftsmen themselves. Merer's logbook, found in 2013 at Wadi al-Jarf on the Red Sea coast, documents in meticulous detail how his crew boated limestone blocks from Tura, received wages in bread, beer, and textiles, and reported directly to Ankaf, the half-brother of the pharaoh Khufu. Egypt recorded everything: supply chains, payroll, stone origins, the exact canal system used to float the blocks to the base of the site. Everything, that is, except the one thing we actually need most: the construction method itself. The obvious answer most people reach for is ramps. Workers dragged the stone blocks up an external ramp as the pyramid grew taller. Simple enough in concept, but to keep the incline gentle enough that ordinary people could haul multi-ton blocks without catastrophic injury, that ramp would need to stretch almost 2 full kilometers in length. A ramp that long would require as much material and labor to build as significant portions of the pyramid itself. And here's the crucial problem: there is zero archaeological trace of that ramp ever existing or being torn down. No debris field, no displaced soil signature, nothing. So some researchers proposed a spiral ramp instead, wrapping around the outside of the pyramid to stay compact and reuse the same incline angle repeatedly. But that generates an arguably worse problem. The pyramid's 4 faces are perfectly straight, and to maintain that straightness, the builders needed constant, unobstructed access to all 4 edges. A ramp wrapped around the exterior blocks every corner they needed to check, so no ramp on the outside. But what about the inside? Could it be that the solution was just under the surface? In the 1980s, someone spotted a fox entering the Great Pyramid near the base and exiting hundreds of feet higher up, through a gap that had no obvious explanation. That fox inspired French architect Jean-Pierre Houdin to propose a hybrid construction system. A short external ramp for the lower third of the structure, which is then dismantled, and the upper blocks are then fed through a hidden internal ramp spiraling upward inside the pyramid for the upper portion. The model elegantly explains the missing debris from the external ramp. Houdin also argued that the Grand Gallery, a tall, narrow bench-lined corridor with deep scuff marks running along its walls, was actually a giant counterweight system used to haul the massive granite ceiling beams into the king's chamber. The theory is coherent and internally consistent. But in 2017, scientists essentially gave the pyramid a full-body scan, and what they found began unraveling things. The technique is called muon tomography. Muons are high-energy subatomic particles produced when cosmic rays from deep space collide with Earth's atmosphere. They rain down on everything constantly, and they pass through solid rock, but denser material absorbs more of them. By placing particle detectors inside and around the pyramid and waiting long enough, a team from Nagoya University, France's CEA Institute, and Japan's KEK laboratory built a 3-dimensional density map of the pyramid's entire interior without physically disturbing a single block. Think of it as a medical CT scan scaled up to a 146-meter ancient structure. The project, called Scan Pyramids, announced their most significant result in November 2017, a massive, previously unknown void sitting directly above the Grand Gallery, at least 30 meters long with a cross-section comparable to the Grand Gallery itself. It was the first major internal structure discovered in the pyramid since the 19th century. The discovery triggered thousands of new theories overnight, but almost nobody mentions what the scan failed to find. What the muon scan did not find was a clean, continuous spiral running just beneath the pyramid's outer surface. If Houdin's internal ramp existed, the physics of muon absorption should have left at least a faint trace of it, a ribbon of lower density material curving upward through the stone. Instead, the scan revealed scattered, irregular voids with no coherent spiral pattern. That does not disprove the idea entirely, but it significantly weakens the argument. And this same pattern keeps repeating across every major construction theory. They work persuasively on paper until you hit the hardest part of the entire structure. Nearly every theory about how the Great Pyramid was built collapses at the top. At the base, there is room to operate. The blocks are heavy but manageable, and the workforce has space to spread out. But as the pyramid grows taller, the working area shrinks rapidly. An external ramp has to be dramatically shortened right when it's needed most. An internal spiral loses its turning radius and makes it nearly impossible to verify whether the 4 outer faces are staying straight. That verification matters enormously. Even a tiny angular error at the base, maintained all the way up, becomes a massive deviation by the time you reach the apex. When you look at pyramids built by other cultures across the world, a striking pattern emerges. Most of them avoid this problem entirely by finishing with a flat top. Some later Egyptian pyramids lost their tips as well. The sharp, perfect apex of the Great Pyramid is not just its most iconic visual feature. According to many Egyptologists, it's the rarest and most structurally difficult thing to explain about the entire structure. And it's precisely the thing a researcher named Huni Choi spent a decade trying to solve. Huni Choi is not an architect and not an Egyptologist. He's a Korean independent researcher who spent roughly 10 years building a 3-dimensional digital model of the Giza plateau, hand-placing thousands of individually measured blocks in a simulation of the entire site. And if you think you've heard every theory already, This might be the new missing evidence of Egypt's giant. His central argument sounds almost backwards at first. The Great Pyramid was not built from the ground up into its final shape. It was carved down from a much larger temporary mass that was previously erected in a trapezoidal shape with integrated ramps. And the ramps, the tools, the construction machinery that archaeologists keep searching for and failing to find, none of it is missing. It was never lost. It was simply consumed by the project itself and misread as finished architecture. Here's how the model works. Before any construction began, the Giza plateau already contained a natural limestone outcrop with small rocky hills scattered across it. Most of the pyramid's core blocks were quarried directly from that plateau, with the finer casing limestone brought by boat from Tura and the granite transported from Aswan, over 900 kilometers to the south. Choi argues the builders first identified the high points in the terrain, shaved them flat, and terraced those surfaces into stable working platforms. Then, instead of beginning with a pyramid shape, they overbuilt, constructing a rough, enormous trapezoidal mass with a ramp system already integrated into its sloped sides. Not a four-sided point, a wide, squat platform, spreading outward at the top, with a safe 7-degree working slope on every side. Once that trapezoidal mass reached its full height, workers began carving it downward into the final pyramid geometry. On a conventional pyramid build, the ramp gets steeper and more dangerous the higher you climb, and the working deck shrinks to almost nothing near the top. On a trapezoid, the deck at the top is the widest part of the entire structure. All 4 edges are visible at once. The slope stays manageable throughout. You're not fighting your way up, you're carving your way down. But that's only half of what this theory actually explains. This directly solves the apex problem that kills every other theory. When you work downward from a wide, stable platform, you have simultaneous access to all 4 faces and all 4 edges throughout the entire finishing process. The builders could continuously check and correct the slope as they carved, rather than trying to anticipate it from below through guesswork. Maintaining the precisely steep 51.83-degree angle that follows all 4 faces to meet at a single perfect point becomes a controlled carving task rather than a blind stacking exercise. The apex stops being the most dangerous variable in the project and becomes the natural, predictable endpoint of a process that has been visible and verifiable from the very beginning. The material math behind this theory is one of the harder things to dismiss. The Great Pyramid weighs roughly 6 million tons. Choi's model estimates the initial trapezoidal step mass at around 8 million tons. That 2 million ton difference is not waste. It became feedstock for the next phase of construction across the plateau, contributing the working mass for Khafre's pyramid and the surrounding structures. The same recursive loop then repeated. Overbuild a trapezoid, carve it into a pyramid, recycle the surplus into the next build. When you add all the stone moving through the system, you arrive at roughly 14 million tons circulating through the Giza plateau, with around 1 million tons left over. That number aligns with the mainstream volume estimates for the entire Giza complex, and this fits the documented behavior of Egyptian civilization perfectly. They turned broken boats into furniture. Old furniture became smaller carved objects. Later dynasties literally mined earlier pyramids for fresh building material. A construction system designed to cannibalize itself and feed the next project is not an alien concept here. It is the most Egyptian solution imaginable. This also dismantles the missing ramp problem in one step. The external ramp theory requires a roughly 2-kilometer structure that left behind absolutely no trace. Choi's model says the ramp was never a separate structure that needed to be built and demolished. The ramp was the trapezoid. When the carving was finished, the ramp material did not need to go anywhere. It had already been reused as the next structure. There was no debris field because there was nothing to discard. The construction evidence was not lost. It was intentionally consumed by the system that produced it. And there may be physical evidence of this embedded directly in the surviving stone. A YouTuber called History for Granite spent years cataloging roughly 6,000 surviving casing stones across 3 faces of Khafre's pyramid and found a repeating pattern. Small, tapered stones forming vertical seams on each facade. In masonry, these pieces, often called bonding or kingstones, slide into place to stitch 2 separately constructed sections of wall together. Their position on Khafre's pyramid is telling. They appear consistently on the faces, but not at the corners and not at the centers. That distribution suggests these were starting lines rather than finishing lines, meaning different crews built outward from multiple simultaneous starting points and stitched the sections together at the seams. And critically, if a giant external ramp had been anchored to one side of the structure throughout construction, you would expect the bonding stone pattern to cluster heavily around that working edge. The pattern shows no such concentration. It's consistent with crews working across a wide, stable, fully accessible deck with clean sight lines to all 4 faces at once, which is precisely what Choi's trapezoidal mass would have provided throughout the entire carving process. But here is the genuinely uncomfortable thought that comes out of all this. Most pyramid theories fail not because something actively disproves them. They fail because absolutely nothing confirms them. The massive external ramp, no debris. The internal spiral, no coherent trace in the muon scans. The water shaft theory, no canals, no cuttings, no retaining walls. Dismissing a theory because its physical evidence is absent makes perfect sense from an archaeological standpoint. But what if the evidence did not vanish through millennia of erosion? What if it was deliberately erased as a matter of religious practice? There's a real scholarly discussion about the Egyptian practice of restoring sacred sites to a state of purity once construction was finished. Clearing scaffolding, removing surplus stone, covering every visible mark of the human hand. If they systematically recycled the construction evidence as part of their spiritual practice around these structures, then the absence of evidence is not a gap in the record. It is the record. In mathematics or physics, proof is final. You run the experiment, someone else repeats it, and if the result holds, it becomes fact until someone disproves it. Archaeology does not work that way. You can't run a live experiment called Build the Great Pyramid and see what happens. Instead, a theory earns credibility when it correctly predicts what traces should exist. Those predictions match what actually shows up in the ground, and multiple independent types of evidence point to the same explanation. Under those standards, Choi's model is genuinely compelling. It predicts a closed material loop, and the tonnage estimates line up. It predicts wide deck access during casing, and the bonding stones on Khafre's pyramid are consistent with that. It predicts ramps integrated directly into the stone mass itself, which explains why no separate ramp debris has ever been found. But compelling is not the same as confirmed. The pyramid is 4,600 years old, and some of its hidden corridors were only discovered in the last decade. There are almost certainly details encoded in that stone that we have not yet thought to ask about. And maybe that is exactly why people keep coming back. Because the answer is in there. We just haven't found the right angle to see it from yet.